Now let's take a look at how we would measure light. And we're going to look at the simplest way you can do it with an Arduino using this photoresistor. And the way these photoresistors work is as light is exposed to the sensor, the resistance goes up. I can demonstrate that with my meter right here. Put it so you can see the reading. And if I put my two probes right here and here, see right now I'm getting about 2.4K. If I put my finger over it, it's 13K. And that's about it. That's all you need to know. What's nice about these is since it is a variable resistor, we can use them with the same type of code that you would use for a potentiometer. In fact, we wire them up fairly similarly, although this only has 2 leads versus a potentiometer's typical 3 leads. So let's take a look at how we wire it up and read the values coming from it. So first thing we can do is just add it to the breadboard, and you'll notice there's no positive or negative on these. It's just a simple left and right. So I'm going to pick rows 1 and 3 on my breadboard. And I have a 10K resistor right here. This one is one of those sensors that you want to pull to ground, so I'm going to put that in the bottom lead right here and pick another row. I'll just pick 10. And the reason we have the 10K resistor in here is to be able to read this voltage or pressure between 0 and 5 volts. We need a current. If we don't have a current, how would you measure its pressure? So that allows the current to flow, and then we can measure how hard it's flowing or its voltage accordingly, and then we can convert that into some useful code. So let's continue building the circuit. We'll start by connecting the 10K resistor to ground. The other thing we need to connect up is 5 volts. So the other lead of this photoresistor, we're going to connect directly to 5 volts. And then let's use a different color for the sensing. The sensing can go to the opposite leg. So this is going to be an analog read on this wire. And when it's not reading, it also can be pulled to ground, stopping any floating. And I happen to know the potentiometer code reads analog 0. So let's go ahead and put that in analog 0 for now. I don't have my Arduino hooked up yet. Let's open up the code. We'll launch Arduino, and we will go to File, Examples, Analog, AnalogInput. And very similar to the potentiometer, this says potentiometer input pin 0, and that there'll be an LED attached to pin 13, which is built into the board right here, as we know. And looking at the code, sensor pin, analog 0, perfect. LED pin 13, that's fine. And this is just a sensor value placeholder. That's where we're going to store what we're reading from analog 0. We just have to declare the LED pin as output. Then in the void loop, we read it, we're writing to the pin, and all of this is based on a delay of the sensor value. So let's go ahead and upload this. I'll plug my Arduino in. Double check my tools. Uno, perfect. And upload it. See, it's uploading right there. All done. Now you can see the LED blinking, and on camera it's a little hard to see, so what I'm going to do is just take an LED and put it into pin 13 and ground. That makes it a little easier for you to see. Now you'll notice that it's blinking about once every second or so. If I put my finger on this, the resistance should be higher. Blinking a little bit faster, but if we go into the code and we look down here, sensor value equals analog read sensor pin, and we make that value a little bit smaller. Let's just start with dividing it by 7. That's it. We're going to take the analog value, let's just say it's 70, and we divide by 7, it's now 10. So we've reduced that delay time. Let's give that a try. Uploading, and now you can see the LED automatically is blinking faster. But as I bring my hand closer to this photosensor, it should get much faster. And there you go, almost blocking the light. Photoresistors have a lot of practical applications. They're fun, they're affordable, and easy to work with.